This add-on is for Blender 3.1 and above. You can find it at github.com/dreamspoon/bigspacerig. To get the latest release, go to the Releases section and download the zip file. I'm using Blender 3.1, so I go to Edit and Preferences and the Add-ons section, then click on Install. Select the zip file from GitHub and press Install. Click on the checkbox to enable it. A big space rig tab is added to the Tools menu. Then exit the Preferences menu. Ready to go! Remove all the objects from the scene and then go to the Big Space Rig tab on the Tools menu. Create the rig that will manage the numbers so we can easily add really big objects like MegaSphere. Clicking on Create MegaSphere, it looks like nothing happened, but we need to move the observer to the surface so we can see what the noise landscape looks like. Go to the surface of the sphere by switching to the Observer tab, setting our latitude and longitude, and pressing Go to Coordinate. This took us to the pole of the sphere, but we have a landscape that has the correct facing orientation. To show how big it is and the different LODs, I'm going to switch to an overhead orthographic view and then zoom out as far as possible. Using multiple nested levels of detail allows for very large spaces to be created with few triangles. I'm switching the renderer over to cycle so I can use the Nishida sky texture. Geometry will render fine in Eevee, but the background needs cycles to work. I'll try some different settings on Nishida Sky to make it a little less bright and more interesting. With this basic setup of Big Space Rig and MegaSphere, I can demonstrate some features, some common issues, and troubleshooting. A common problem that happens when using non-90-degree latitude and longitude is a subdivision problem. The problem looks like a landscape that's not detailed enough and it seems too far away. With MegaSphere selected, I'll go to the Geometry Node Editor. The solution is to go to the MegaSphere node group and change the subdivision scale to something higher. Usually 15 solves the problem for all different spots, although setting it even higher might be necessary for larger radius spheres. The geometry generated by MegaSphere is quite large, so it's necessary to go to the View menu and change the clip start and end value. The end value determines how far away we can see, and if we change the clip start to a larger number, it helps give us more detail in the space that we can see. When doing the final render, these numbers need to be transferred to the camera as well in the clip start and clip end of the camera object property. I'll check the render to make sure that things look okay with the new clip start and clip end values. In the bottom right of my Blender viewport, I have some statistics showing the number of faces, number of triangles, and so on in the current scene. I'll show you how I get those values. I go to Edit, Preferences, choose the Interface tab, Editors, Status Bar, Show, and Enable Scene Statistics. Watching for differences in these numbers can help us to find when there are problems or figure out when we've achieved success. For example, if there are 0 triangles, then we have no geometry, and that might be a failure. To check that subdivision scale of 15 is working correctly, I'll visit a few different latitudes and longitudes. Everything's looking okay. I'll show the fields of the MegaSphere group and go over as many as I can in a troubleshooting kind of a way. I'll change max faces up and down so we can see how it affects things. It's used to limit the maximum number of faces generated during subdivision. Originally I used it to prevent Blender from crashing from creating far too many faces. I'll increase the width of the node group so we can see the full name. Max number of subdivision relates to the smallest level of detail that can be achieved using subdivision. Setting this number higher will give more geometry and more detail in the center. Setting this number lower will give less geometry and less detail in the center. Internally, MegaSphere has a max number of subdivisions of 27, so setting the number higher than 27 won't increase things past 27. Cull distance will not affect the level of detail, but it will reduce the amount of total geometry that's output because it deletes any geometry beyond a certain distance. I'll set it to 1000 so we can see it shows geometry only within 1000 meters of the center and deletes all the other geometry. And by center, I mean center of the MegaSphere object. So if the MegaSphere object is moved, then it will move all the geometry too. The cull distance is in meters, and you can set it to very high values as needed. For example, the cull distance displayed here is 100 kilometers. To enter large numbers, it's sometimes easier to use exponential notation using e. So for example, I can type in 1e5 and it's the same as typing in 100,000. 1 with 5 zeros after it. When working with these large distances, sometimes it can be hard to find the center of the rig or move around, so I'll demonstrate how we can quickly select some bones to make it easier to change the view in the rig. I select a bone and zoom in by pressing the period button. Alternatively, I could use the view menu in the 3D view and select frame selected. Now I'll switch over to the observer 0E and see where it's sitting at. Finally, back to the observer focus. This one is usually at the center of the rig, so it's a good place to zoom into if you've gotten a little bit lost in the 3D view. I select the observer 6E bone and show that by moving it we get huge movements, times 1 million. The movements are so large it makes the whole terrain disappear, unfortunately. Going back to the observer 0E and framing it in the viewport, I see that by moving it, I'm moving the landscape at a 1:1 scale. Zooming out a little, I can move it a bit faster and show how the levels of detail change dynamically. I'll change the view back to the center and see how the LOD changes as we move the observer up away from the terrain. Back to the geometry node editor and reset cull distance to 0 so it's at max. I need to zoom out a bit now and change the view distance to show how Vis Angle Adjust works. I set the clip end to 1 million. That's the same as 1e6. Vis Angle Adjust is like Cull distance except for the angular distance instead of the XYZ distance. The value can vary from -1 to +1 and it represents the cosine of the angle. Positive numbers reduce the amount of geometry generated and negative numbers increase the amount of geometry generated. This is easier to understand by seeing it instead of just hearing it. Even though we're only looking at a small section of the sphere's surface, we have generated a very large area of geometry. It's about 300 kilometers by 300 kilometers. That's massive. It might seem that this would be a problem when it comes time to render, but Blender is able to handle it just fine, even in the viewport. The only difficulty I've noticed when rendering at these distances is using volumetrics. They tend to crash my Blender instance or don't work properly. And now I need to demonstrate something a little bit strange. What happens if we go underneath the surface of MegaSphere? To do this, I go to the Observer tab and use the go-to coordinates with a radius 0e that's negative. I'll quickly go to Geometry Nodes and reset Vis Angle Adjust to 0 before I continue. I see that the inner LOD ring is not enough detail and I want to increase it. I go to Subdivision Scale and I increase it. But no matter how high I increase it, even to 1,000 or billion, it doesn't increase the amount of subdivision. Using go-to coordinates to go underneath the sphere's surface can sometimes create problems in the sphere generating. To continue, I'll set radius 0e to 0 and go to the sphere's surface again. To work around this problem, where we might want to offset our geometry downwards, we can do it in the geometry node setup. Noise has a multiply node, which increases and decreases the size of the noise. And an add node, which can be used to offset the whole geometry set up and down. The geometry moves up and down along the sphere's normal, so this will be correct at any point on the sphere's surface. Here I'm just showing how the geometry looks after the changes to the node setup. I want to add a texture of the Earth to the sphere, and I'll show you how we can use one of the attributes, sphere normal. To use it in the material shader, I need to name it in the geometry node modifier. I also set the material so it's applied to the geometry. I name the attribute sphere_normal. And switching over to the shader editor, I set the material, and I can't see the nodes. I press home to frame all nodes. Now I can see what I'm working with. To get the sphere normal, I need an input attribute node. I'm using an add-on to make things easier when working with nodes. The add-on can be found in the Edit menu, Preferences, Add-ons, Search, Node Wrangler. The name that I type into the input attribute node needs to exactly match the name that I put into the geometry node modifier, so that Blender can connect the two together. Instead of a regular image texture, I'm going to use an environment texture, which will take XYZ values instead of UV coordinates. The XYZ values are the sphere normal values. I'll just demonstrate how I can use Node Wrangler and press Ctrl, right-click, and drag to cut a node link to remove it. Here I need a high-resolution texture of the Earth, which I can get from a NASA website. The Visible Earth NASA website that I show here, it has many pictures of Earth at different times of year. Some of them are cloud maps, some of them are height maps. I'm going to go for a color texture map from July. I'll put a link in the description. There are a lot of options. I have to make sure I choose the right size. 21,600 by 10,800. If I go for the next size up, the square size, it doesn't work right. I right click on download and choose save link so that it won't open the picture in my browser and take forever to download. It's faster to just save. Back to Blender, and in the environment texture node, I'll use the texture I just downloaded. I'll reduce specular down to 0.001 and increase roughness up to 0.5. Looking at it in rendered view, I see a not very interesting landscape. We are at the pole of the Earth after all. I need to go to the map to find a more interesting location. Greenwich, England is of note because it lies almost on 0 longitude. It was originally the prime meridian. Given the numbers for latitude and longitude, I can just copy and paste into the fields for go-to coordinates. It's easy to paste into a Blender field by putting the cursor over the field and pressing Ctrl V. It's hard to see because we're zoomed in so far, and the texture becomes a bit blurry at this point. I'll zoom out so I can get a better view. After zooming out, I get a good view, but I still want to see more of Earth. I'll go back to the Observer tab in the Go-To Coordinates area and set the radius farther away from the surface. Adding 0.1 is the equivalent of adding 100 kilometers. We are now 100 kilometers above the Earth's surface. I want to remove that grid from the view. I go to Viewport Overlays and turn off Floor. Now I can see better. It looks good. I can see the curvature of the Earth. Switching to wireframe, I can see that those LOD rings are gone, and now I'm just using a subdivided icosphere. As I move further away from the sphere, I see that the number of subdivisions decreases. To see how far I can push this, I'll go very far away from the sphere's surface and go to rendered view. Looks good. In the next part of the video, I'll demonstrate places in the big space rig that let us put things accurately on the landscape so that we can come back to it later and not have to worry about things being out of place or overlapping. To demonstrate, I'll start again from fresh by creating a new MegaSphere with the default noise landscape. In wireframe view, I can easily see the results from the changes to the geometry nodes. I'm going to modify the landscape a little bit to make it better for use with physics. I reduced the max number of subdivisions so that the center ring disappears. I want to have an even distribution of faces without a cluster in the center. And I reduced cull distance to just 30 meters because we currently have a radius of about 100 kilometers of terrain, most of which we wouldn't use for our physics here anyway. This should be large enough and with enough detail to do a very nice rigid body simulation. I need the timeline back so I can scrub through the animation. Then I'm going to add a Suzanne. To make this more interesting, I'll move the Suzanne around, rotate and scale a bit. I remember to apply scale before I do any physics animation so things work right. I can add physics to the Suzanne monkey head from the Physics tab. Rigid body. In the shape type, I choose mesh and it looks like a monkey head. Perfect. I make the MegaSphere a rigid body, but this one's passive, so it won't be affected by gravity, but it will affect the monkey head when the monkey head falls. Even though our MegaSphere isn't a monkey head shape, it still is not a convex hull, so we need to choose Mesh. The deform type needs to be set to final, so it will use the output of the geometry nodes to create the physics object. I can press space to run the animation and calculate the physics. Because it's only rigid body, it calculates in real time. This is good, it looks like it is interacting with the landscape. I want to bake the animation so it doesn't have to keep recalculating every time I play the animation. I'll go to the scene properties, open up the rigid body world tab. In the cache section, I can find the bake option. I'll do 100 frames to test. With the current setup, everything looks right. So I'm going to show what would break this setup and how to fix it. In the Big Space Rig Observer tab, I do go to coordinates to go just 10 meters above the original location where I baked the physics. Running the animation again, I can see it doesn't drop all the way down to the landscape. The landscape has moved, but the monkey head has not. A simple fix is to just go back to the original coordinates, but I'd like to set it up so that the monkey head will move with the landscape. To start, I'm going to bake the rigid body physics animation to keyframes. I press F3 so I can search for what I want. I type in bake, look down through the options, and eventually find bake to keyframes. Doing this will remove the rigid body simulation, but it does convert all the movement to keyframes for me. This is critical because a rigid body with a physics simulation will not properly parent to a place, or anything else really. There is another method to fix the physics simulation problem, but it's beyond the scope of this video. With the monkey head selected first, and selecting the Big Space Rig last, I can go to the Place tab and add a place. I want to create a place and attach the monkey head, so I choose Attach Single. A square has appeared in the Big Space Rig to represent the place. Running the animation, everything looks the same. To notice the difference, we need to change the location of the observer. I'll move the observer to be 10 meters above the landscape like before and see what happens. The square representing the place and the monkey head attached to the place have both moved with the landscape. That's it for this video. Remember to hit subscribe so you'll be notified when the next video comes out.